Alright.
So what you've run into?
Let's see what it's not up yet. Computer in that bad. So
Oh.
remember. Sweet.
I'll put it on top. Something tilting.
Yeah.
It's not going. Alright, let's try this. Oh, it's up there. Oh, my new Wii wallpaper. Is that coming up? Let me try changing resolutions real quick. Oh, there we go. Yeah, I think I pulled.
Playing the Wii.
Oh, my. Alright.
Oh, you got a tennis game on it?
Yeah, the Wii Sports that it comes with, it's pretty sweet.
Oh, maybe I'll try it out.
Alright, NB project. Open that. Alright, we'll also we're gonna take a look at he thinks he can code. We'll take a look at what he did. Thinks he can make the hot simulations. I know, I was like, I didn't take a look at it because I was taken aback by the whole thing. I was like code.
It's mostly done. I want to check, make sure it's the right setup.
Oh, I'm on desktop. Open. Here we go. Oh, won't fit. Make it smaller. Alright. Smaller. Alright, so what we got here.
Whoa, when did that do?
Which one?
The network simulation.
Oh, this Reed sent this to me. So you as far as I know, if like all the stuff you checked out in CVS, it's under some base directory. If you create a new project in that directory, like I just did it right, then it'll show up with the the little cylinder thing that says that it's not updated, and you should be able to commit it directly from there, and it'll create a new one. I don't think I did anything different. Let me see this. Yeah.
I tried to submit and told me to create a folder.
Okay. So did you just do like a new project, like in a thing like this?
Separate file.
I don't know what I did differently because it just worked. I was actually surprised. I created a project and everything, and it had the little update icon on the thing, and then I just hit update and it checked it in. So I don't know. You might want to try it again. Like as far as, are you sure? Did you do it in the same subdirectory as your other projects?
It's not in base, it's under.
Whatever Pace is in. So like if you have like a peer-to-peer directory and you have Pace and you have cluster and you have like parameter sweep and all those directories in there, you create it in there, in that directory. One over. Yeah, put it in that directory, like the same parent directory as Pace, Pace GUI and all that stuff. If you put it in there, it should, I think, see it as another thing to check in. So, all right. So, all right, what do we got? I haven't taken a look at it yet. When I got it yesterday, and said, "Oh, that's stuff."
Yeah, that's weird. All right.
You can come on this side. Get out of the way. Excuse me.
This is pretty straightforward. It's just all the test values for what I'm trying to test. All the equation values essentially.
Okay. Well. All right. You have a habit of doing this. You're familiar with it, so you say, "Oh, this is easy," and then you just walk by it. So,
Was not much.
if there's something easy,
There goes.
you have a muscle spasm of some sort. All right.
I'll run this one.
All right. Richard might not be able to sit next to the projector and things until he goes to like a chiropractor or something. Better. All right. All right. So
explain
okay, look. When you run it, okay, you have some simple values here that are fairly straightforward. You take that time to orient everybody to what we're looking at in code.
And what the
Some of the equations that you might have been working with, like intensely with while you were coding all this, whereas none of us really, I don't know, did you think
Got
about his equations at all when you were over break? Yeah, I didn't think about them at all. So for me, for my benefit, maybe not these guys, I know these guys are closely, but this stuff we just talked about was really interesting.
take a crack.
Just doing it over this week. So,
Okay. It's just
so like, what are these test values and default? Okay, default time to live. I can imagine what that is. Is that
it just counts the number of pops
Going out
for
the-
the message
okay?
for each time it goes.
Okay.
Later on, I'll show where a counter is for the entire pass messages.
Okay.
But that's just for an individual tree range. How it travels.
Okay.
Uh,
So what are some of these test values?
Node test value is just the total number of nodes in the network.
Okay.
Neighbor test value is the average number of neighbors each node should have.
Okay.
Files is the number of unique files.
In the network.
So the number of possible things you can query for.
So there's no average number of files per node. It's just going to divide them equally.
For now. Number of trials is just the amount of times you run the
Number of queries you run on the same network, or
right.
okay. So this going to be with the same network and same files.
Right, and then it just doesn't average at the end. And top X is the top percentage
For the store?
for the smart test. The top percentage of the store. So,
Okay.
this is my
Okay,
message.
so what? Well, first of all, just to catch us up, just to refresh, the central idea behind your algorithm, behind your protocol is somebody queries.
After a certain threshold, well, each peer will report each query it sees, and just mark or take note of which query it receives and how many times it receives that query. And then after a certain threshold, say 10% of the test or whatever, it starts caching the index to who has the file.
Okay. So if it sees the response of the query, it'll start.
Right now, just
When it sees a query come in, or that someone's interested in it, or when it sees.
right now it's just the receiver that does it.
Oh, okay. Wait, the file receiver.
The file receiver caches who has the
Okay. So intermediate ones that are processing the query and propagating the query, they don't do anything with the queries.
well, they pass.
Right. Oh, yeah. So they do the propagation or the request or whatever, but nothing as far as caching goes.
Simple message class, just as who originated the file, or who originated the request, what they're requesting and the time to load. So it's just for counting number of hops it goes through to get to the whoever has the hop. Version of Node. This is. This is the dumb node. It just takes a request. If it has it, checks to see if it has it. If it does, it returns that it does have it. Otherwise, it passes it to all its children or connections to the children. It's got a lot of helpful functions. Really, that's all it's really is. That's also got some stuff to help determine whether or not it's connected to the network or fully connected to the network. I mean, this is really just this is the interesting part. Just it says, you know.
Okay, so we get something.
I also had to break it out so it wouldn't be a completely recursive thing where it just goes straight down and come back up. So it's I don't want to recurse the tree. I wanted to individually do each one.
Oh, you didn't
I
want to. Okay, you want to go breadth.
I wanted
Breadth
to go
first
in
instead of
order.
depth first.
Yeah.
Okay.
So I broke it out into two processes. One's receive and then just hold the message, and then the node gets queued, and then the DQ and process it. And all its children get queued behind whoever else is in.
Okay.
And this is most of it. Constructor takes all the test values that passed in and just holds them.
Wait, what is this? Is this a?
This is constructing and testing.
Okay, so this is a simulation object. This
Right.
object is a simulation environment. Node is the node, and then I assume smart node is another iteration that
Right.
has the caching.
Mhm.
So testing normal is one run,
One
the-
or it's
or however many you want to do, but it's a run of.
it's the run
Simulation.
for that network, that setup of the peer-to-peer network.
So it builds the network,
Checks to see if
populates the files, and then starts running random queries.
Right. It also does some checking to see if it's connected, make sure everything's alright.
So let's see the. So this run me is the main routine.
Yeah, run me is just go do everything you need to do.
Okay, so we start off doing what? This is.
Just initializing some of the stuff, but I changed the name so it'll be easier for me to read and edit. This one just creates each node. This section will do a connection, make sure that if the node is already connected to that node, it won't do a new connection.
Okay.
So if I connect to you and then
So the connections are set
Yeah.
so that you don't duplicate. Okay, and
the
then.
generator says connect to you again, I don't.
No, wait, let me see what we're doing here. So you iterate through all the nodes, get the ID, you randomly generate a neighbor. Rand is
Randomly generate at least one name.
something to connect to, right?
Right.
Oh, that's the number of neighbors, okay.
Right.
And then,
Who's doing it?
what's
So
the rest of that random generation? Number of neighbors. Oh, because you can have up to the maximum number, up to a complete set of neighbors.
Right.
Okay. Generator next in, number of nodes. So you create a new connection to any of the connection.
Create a new connection to any node, not itself.
Okay.
And then I go through, find that node, and do set the connection. And make sure that it doesn't already have a connection. I might be wrong.
All right. So you have the connection. All right. Then what?
through and make sure that each node is completely connected to the network. So it just picks a random node and iterates through all the children, and a set a flag in each node to just to make it easy on me. Set a flag in each node that I can set to true. Just check to see if it is connected to the network. And if any nodes aren't connected, then we go through our connection routine, just choose somebody at random, connect them, and then we'll have to go back and test the whole thing again.
But go back up to the connection list.
Okay.
Yeah, you should just iterate through them. You're choosing one and then iterating through.
Or choosing one, getting all the connections it has, queuing, getting all the connections, and then running through each one, seeing if that's
Just do n squared. Just go through all of them. Go through all of them. Do a tree search, like a breadth first search or a depth first search, and then just go through all of them and make sure. So after you do a depth first search, like a tree search, like a breadth first or depth first search, right? You do a tree traversal, and just have a list of the nodes, which of one you visited. If any are left out, that node's not completely connected. Iterate through all the nodes and do a tree first search. In other words, root the tree at all the nodes, and any of them that have nodes that are not leaves or nodes that are not connected, then you're not connected. But yeah, don't bother with like random and stuff. I mean, just iterate through them.
Alright.
You're thinking too much like an an application. Like, oh, that's going to take a long time, or maybe I can just do a sampling or whatever. It's a simulation, so just
who cares?
know. It's like simulations have so many unknown values to begin with. Anything that you can know it. You know what I'm saying? It's like if it takes a long time or whatever, or and if it does take a really long time, and
So
tree searches or whatever of n nodes, it's like if you're going down the tree, it's like you have to visit each node, so it's like an n squared type of thing. N squared, just looking at something for 1,000 nodes or whatever, that's nothing. You should do that all day long. So I mean, whereas n squared of like communicating over a network and sending messages and all this stuff, that might not be good. But in simulation, that's why we do simulation, is because no holds barred. If it takes, it's like if I have 2 million calculations that I can do here real quick, I'll do it. It's like so I can get that I can know. I know it that way. That's one less thing I have to worry about as far as these unknown things, or how my simulation doesn't match up with the real world, or how my my algorithm has a random, like a stochastic aspect to it that sometimes I'll get a good value, sometimes I'll get a bad value. So solidify everything, and just don't think of it in simulation. All the things that are completely impractical in the real world, that's when you do them, because you're in simulation. Because whereas finding if every node's connected in a peer-to-peer network, that's hard. It's like somehow coordinating, talking to every single peer, and if you can talk to every single peer, why are you checking if they're connected? Just connect them, kinds of things. You can't do it in a real application. So now that we have the luxury of being able to do it, so just do it. So yeah, and it'll look ugly, and it'll be counterintuitive to write code like that, where you say, okay, I'll just iterate through everything and do a whole depth first search of the tree that they're connected to, that they're rooting. Even though you wouldn't do that probably in a real application, just do it. So so after that, after checking the connections, then we get into running it. Okay, so by the end here, we haven't done files yet, have we?
No, not yet.
Oh, okay.
So this was some debug stuff I put in just to give me.
Yeah, how's this average number of neighbors being related to everything?
I just go through and find out how many neighbors each thing has, because it generates a random number of neighbors per node, up to house.
Up to everything, up to
Yeah.
full connection. Okay.
So I just want to check, make sure that I was getting the right
How are you
distribution.
getting the?
How was that calculated?
Yeah.
I was going through.
I mean,
Each
I
node?
can see. I mean, you calculate the average number of neighbors by just iterating through and counting the number of neighbors and then averaging them. But how are you getting towards that target?
For,
In other words, if you set an average number of neighbors of 3, when you're generating your network, what would tend to make it go towards that average, or is that just what
It's
you're
just-
expecting?
it was just the I don't know. I ran it like 100 times, just watching it, just up to that point,
Uh-huh.
and was getting. I had it set at 2.9 to 3.1.
I mean, you were getting that by just doing the.
Just running a different network each time.
Okay, but so that is an expected number, or is that the target number of the average neighbors?
Right here as well. So it's doing at least one neighbor.
Is number of neighbors the value you set, or?
Yeah, it's the test value.
Oh, okay. I was confused. Hold on.
That gets from the neighbor's test value, the all cap letters. That just gets put into that variable.
Okay. I thought that was number of nodes. Okay. Okay, so that would do it. Yeah, that would get 10 towards that.
Yeah, it was pretty close. I mean, it was,
Well, wait. No, it wouldn't tend towards that. You're probably tending towards it because it was small. Because you can't get above that.
Right.
You can't get above the number of the.
so if I set it at 100,
Look, yeah, I mean, if you put it,
Yeah,
if you say average number of neighbors 3, you can't get 4 neighbors.
because when I did it times 2, I did this times 2, I was getting 6 on average.
If you did what times 3?
Number of neighbors times 2 minus 1 plus 1.
Okay. Where you tried to put the average in the middle? Where you tried to put
Yeah.
3 in the
So
middle?
I just tried to double my ceiling and then say, okay, we'll probably get halfway.
There's something about statistics we should know here. And I credit myself with the experience to know that, even though I don't know the answer. No, you need to make, what you actually want is a choice of number of neighbors that covers 0 or 1, I guess, to the number of nodes, where the median is at the number you want, at 3, for example. So you want the center of the big hump of the curve at your target value. And there should be a straightforward way to do that at the moment I have no idea what it is. And it's probably something really silly that, again, we should know. But being a computer scientist, I am statistically crippled. Okay, that's 1, right? 1 neighbor. This is n nodes. Okay. What a bell curve is, or what a curve that shows random distribution would just be if I were to run this random number generator a gajillion times, right, an infinite number of times, and plot how many times I got each value. So, 6. Every time I got a 6, I'd add 1 to the counter, right? And then the counter would be, if we were to do a histogram, it would be, I got 1 of them, it goes up here. I got 2 of them, and it would just be a height, right? So, if we ran this an infinite number of times, this random number generator, what we want is a distribution that if our target value, x is right here, right? We want the distribution, the histogram, to look like this. We want it to go like that. See, so that we get this number the most, and that it's balanced on both sides. In other words, even though it's shorter here, doesn't look very good. All right. See, so all of this needs to equal all of this. See what I'm saying? Because if that's the numbers you chose from that distribution, you tend to have a mean of X, which is your target X. But it won't be exactly that. It'll tend to either side of it. So you need to make it do that. Whereas RAND is uniform distribution. Uniform distribution is like this. So there's an easy way to do that. I don't know what it is, but that's what you'd want. So for now, you're just choosing from a random distribution and then running a bunch of times and hoping that it gets towards what you're doing. So if you set that to 3,
Yeah, that's great.
it comes out to be what? 2 point
It was range between 2.9 and 3.1.
at the average? Okay, what about the range of like?
Wait, you have a fixed number of nodes, like how many
Yeah,
it's
there's,
gonna generate?
you set the node value as well. So you have fixed
Or
number of nodes,
neighbors, or
fixed number of neighbors.
then
See,
it would automatically.
Your mean might be 3, but your range is not 1 to n, or anything near 1 to n. What I mean by that is if you were to look at all of the number of neighbors of all of the nodes, they're all going to be around 3, which is not what you want. You want them to average out to 3, so that some have 1, some have 4, 5, 6. Right? But what it would end up being is that in 1,000 nodes, you'd want probably a small handful of them to have 1 to 3, and then maybe you'd have a lot of them having 1 to around 6 or so, and then maybe like 1 with n minus 1 or 0 with n minus 1. You know what I'm saying? Because what you're doing here is you're actually having a very compact, like each of them's like really compact with just 3 nodes. It'll look very uniform. All of them have 3. I'm just wondering if it matters. I think it matters.
Most likely. I mean,
It'll at least be
Yeah,
more
it'll
interesting
be
if you
hard to
see
change.
a bigger range.
Just have to be smart about what to change. Let's see. That's connected.
All right. So then after that, we have to do the. Okay. So that's your printout of after generating the network, right?
Right. Just stats.
Next is distributing
This,
files.
just it's even distribution. I just take the number of files and
Okay.
fire them out. So random node.
See, so that actually will, like, just choosing a number of,
Just take the
just
file
randomly
and
tossing them out there,
Mhm.
you'll create a nice bell curve. You just randomly choose a node, right?
Right.
Yeah, you randomly choose a node and then add the file to it.
Right.
See, that'll actually look really neat because you'll have a bell curve where some of the nodes, a lot of the nodes will have about number of files divided by number of nodes. So they'll tend to be number of files divided by number of nodes, and then you'll have a few that have tons of files and a few that have very few files. So that's what you want to make it look like, except the other side.
So, and then this is the query.
Okay.
So the 2 values up top, the double app hops and the app messages, those are just the values for doing statistics later.
Okay, for checking.
Right.
Okay. Let me see your comment. Okay, so choose a random node to make a query process. Query the nodes until file is found. Okay.
So I just go to the first return string.
So what do we got here?
This is to essentially you choose. So you create a message and randomly select a node to generate that message. Go through the nodes, find the node with that ID.
Okay.
And then queue the message with that node.
Oh, on the node.
Right. You just I kind of closed it because I just made it like the node was the only node ever to receive that message.
Okay.
But it worked. And then basically goes through all the children of that node, or checks to see if the node has it. If the node doesn't have it, goes through all the children of that node, and then passes in the message, and requeues each node. Until it's found. And that's the total messages passed in the whole network.
Wait, where?
That counter. message is passed. And looking at message. It'll recreate the message and reset the message to be time to live minus one.
Okay. It'll recreate the message
When
and
it
just
passes.
decrement the counter. Why are you recreating the message?
Just
I mean, why are you using the same message?
makes sense. So let's see.
Your sense is wrong. No.
What's the difference? Anyway,
No, it's just not. I'll get the. It's a message. It's a message, and it should just live.
continue.
It should go through and then eventually be done, and then.
Well, I was also afraid that if I think when I was thinking about it, I was afraid that if I was referencing the same message in each node, then I'd be flying through that counter.
Right. But then that means something's wrong with your processing, right? So you wanted to nip that in the bud and just
Pretty much.
make sure that
Make sure it went alright.
create a new object. And,
I don't like problems. So alright, so
by the way, doing that doesn't solve the problem.
Oh.
It hides it. That's a good way to hide problems.
Alright. What seems to work. So.
But objects are the way businesses make it so you don't hide problems. Right? That's why they did object oriented, so that you can
Find them.
treat it like an object. If you treat it like an object and it gets all the way through.
That's good.
Alright, so that thing hops around. We're tallying the number of hops and messages for each. What is this down here?
This right here?
Yeah.
This is if it is found. Like, this condition to say that if it has the message and or if the node has the file, then it'll return true. Otherwise, it returns false. So if the queue is not empty and this returns false,
Oh,
it'll,
try again.
yeah, it'll just keep going past the message. But if it does have it, removes the node from the queue, gets the time to live, and then the real time to live is the difference between the default and
Yeah, the max time to live and then what you decrement it down.
and then you just you add that to the average hops, and that average message is just the counter, because that's all divided at the end. It's all divided by, like at the bottom, average number of hops divided by number of trials. Prints out the individual stuff. That's just debug. Prints out the individual stuff for that message. So hops.
Yeah, so just the stats on the message that. Oh, that's not even if it's found. Oh, that is if it's found.
Yeah, if it's
Okay.
found.
Once it's found, you get a little printout of. All right, and then you remove the queue
Clears
from
the
the queue
queue.
because you're done with that query. So that query's processed and done.
And that's just a little error thing.
Okay. Something.
If the queue does become empty and it's not found, I don't know what happened.
Because we tested for connectivity already. So.
Right. And then at the end,
Wait, weren't we randomly testing for it? Did you ever hit that message?
I ran it 100,000 times or 10,000 times. So, and just at the end, print out the stats for that run. So average number of pops, average number of messages.
So the number of trials is the number of queries you sent to the Zoom network, right?
Right.
I do not like our constant names. Variable names are a lot better than the constant names.
I use those when originally I did the whole thing in main, and then thought about it for half a second and decided that I would be able to do, or it'd be easier just to put it in two classes.
Pieces of it.
For the smart node part and the regular
Right, so
part.
you can interchange objects.
And one
Originally, you started just writing one big.
Originally, I just did the whole network.
Then you realized that people weren't lying about like object orientation and modularity and stuff.
I've relearned it.
Yeah, it's pretty tight.
And
The general goal is learning once.
Yeah.
The general goal is learning once, using often. But yeah, I mean, there's multiple approaches. So let's see your smart note.
Basically the same. It's
If it's basically the same, you're not doing anything. It's actually radically different,
okay.
right?
Radically,
The idea
yes.
of caching now, as opposed to just running the queries, that's the idea, right? That's the central idea. If it's basically the same, you're not doing anything.
Still a node.
Okay,
Alright,
I got a question.
Yeah.
When do you like? Is it caching like either like you the node is sending out the query, it's caching? Which one does the caching? I think
Yeah.
Larry asked.
Right now, the sending node does the caching.
Sending node does the caching.
The originator
Okay.
is the guy who caches. And I'm
Which-
cheating.
That actually makes sense. The sending node doing the caching.
Mhm.
You know what? 'Cause, I mean,
You see what-
there
do the
aren't
same
really
thing
any
over
other
here.
people to do the caching.
Yeah.
Because anything along the middle, it would be completely arbitrary as whether you can. Because remember, like towards the end of what we were talking about,
Propagate all the way back.
there's a cheat. Yeah, there's a cheat somewhere in there if anybody other than the sender caches, because that would mean seeing the message on the way back, which would be slow. But I don't know what happened when you cache it the sender.
Decreased it.
Okay, cool.
No.
Let's see.
See, the rest of this or see?
Let's see the caching
What
mechanism
percentage?
that you've added.
What percentage did it decrease?
I think I was getting an average of like 5.5 hops, and you know, 4.8 for this one. But I cheated on this. I didn't do the indexing. I just actually added it to the list of files
Oh, so as if it had the file.
as if it got in the file and never got rid of
Wait, hold up. So you
I mean,
never,
it should be +1, right? Like plus one additional hop. Me hopping to the thing. Now, did you add an additional hop? And your average went down to what?
it. 4.7,
From
5.5.
Still a little bit.
we need to know more about what that average means. In other words, what's the range of that? I've learned my lesson about averages.
Yeah.
Looking at an average doesn't tell us anything unless we have at least some semblance of an idea of is the difference between 5 point whatever, is the significance of that difference. What is the significance? Is 0.1 difference in average, is that significant? Does that mean that over a million trials we're getting tons, a lot lower as far as, you need to know the significance of those changes. So we'll look through it and see what other factors we need to know so that we can see that that's actually a substantial decrease or, not much. But yeah, that's saving a whole hop. I think you need to make sure you add the one. Because your idea is that if you add it to the list of files that thing has, what you're saying is that if I were to get that query, I just do the one additional hop in.
Right.
There it is.
Oh, okay. I got a question. So, would it work like, say, you send it, and then say one node sends it, and he sends it whatever reaches your threshold, so he caches it, and then say this one sends one for that query, it gets to him. Does he automatically go to that one? Is that how it
Yeah,
works?
he would forward it, but right now I've got it as he would just reply with,
Right.
I've got it.
So
Oh.
adding it to the list of files you have, adding that index to the list of files you have, is like connecting the tree there.
Okay, I got it.
So it's like that, except for
Except
you're getting
to
a
add
free
it.
hop.
Yeah.
So you're getting a free hop because when it gets to you, you're saying, oh, okay, I have it, as opposed to, oh, me plus one has it. But there's something
It's not-
fishy
is
going
there,
on.
Is there a constant? Is it a random number of messages?
No, the number of messages is the number of trials you run
Okay.
for that given network setup.
Hold on. So
How are they set up? By the way, I missed. I know you did a presentation. I wasn't here.
how many trials are you doing?
I think I had
Can we call those queries? Sure. Okay. We're gonna call those queries. How many queries are you doing in a row?
just
No,
I
what's
don't
what's your value?
10,000.
We're doing 10,000 queries. How many nodes?
100.
100 nodes, 1,000 files.
I did it pretty easy, man.
So we should hit each file on average about 10 times. Over 100 nodes.
But yeah, I see what you're saying where the average is not really tell because one can do it, one.
Point one could be
and
huge.
then the other one is, say you have
And
two.
this is a phenomenal algorithm because we got 4 point whatever, or which I don't, because if we're getting a free hop and the scale that we're talking about is 5 hops, so something's not happening. You see what I'm saying? If we're getting an average of if we're basically getting a free hop, and you're towards the top, well actually no, if you're 4.7, the difference is about
You can't
is a
tell
little bit
from the
under
average.
1.
You still can't tell from the average.
Yeah, you can't tell from the average. But no, what I'm saying is you can't tell from the average barring no other information. But what I'm saying is we have other information. We know we're getting a free hop every time we hit the cache. And if we're caching, 40%
Right.
of the queries? How are you enforcing that? Where's TopX used? Oh, that's right. We haven't seen the cache. Let's look at the caching. We haven't even seen the caching because it was waved off as basically the same. Let's see the caching.
All right. All it's got to do is it's got its recently received messages, so it doesn't take the storm. Possible queries, just all the possible queries that the network could have, and a query counter, which I use for something important. All my helper functions.
All right. So this is where it gets interesting, right?
Right. So, if it's the same message being passed back to it, it doesn't do anything.
Uh-huh.
If it's a new message, it increments the query. The message corresponds to the index of the possible queries. And it just increments that, yes, I received one more of those. Query counter is...
Alright. Possible queries are indexed on what? The source? Or on the
on the total
file?
number of files.
On the file, okay. So we've seen a request for this file. Okay, every time we see a request for that file, okay. Okay.
And that's just the inquiry.
Query counter is just how many queries we've received.
Right. So once we get above our threshold, which happens later. And this is...
So right now this is just looking at the queries we received, okay? Where do we process?
that just adds it to the queue. Make sure there aren't more than, I think history's set at 10 right now, just more than 10 files in the queue. Process, if it has it, yes. Otherwise, pass it all to children. Connections. And all this is handled in
Huh?
all this is handled in the main
Right.
testing.
When do we call clear possible files?
I don't think I ever did. I think I wrote it and then didn't use it.
You used in the constructor.
Okay,
Oh,
so
yeah.
just to zero out the possible queries.
Yeah.
All right. Now let's see. Determine top X. Where do we call that?
That gets called in testing read.
Cut and paste object orientation, man. I tell you what.
Yeah,
I cut and paste, so it get you and run into that crap QA.
It makes the code reuser cry. All right. So what do we got?
just it gives an array and top 40% of the possible files are returned with the array, and then it iterates through the array and says,
Well, this is a global top. Yeah. No.
no, it's for that that node.
Oh, for that node. Okay, so this is just processing for that node, and then it will add that file
Right. If
for the top X.
the sending node has seen the file and it's in the top 40% of that node's seen files, then it'll cache the file.
What does he determine top X? Okay, so we have possible queries. Then you sort them, right? Then you grab the top.
Well, I just basically sort. I go through, grab the highest value, set it to -1, and put the highest value into
Right.
right. And then I return my hit my 40% or whatever. X.
X. Alright, let me see the query processing again. That's what we do. Alright. This is after a query's done. After a query's done,
Right after it finds it.
we'll grab a top X and add it.
If it's in. So,
Basically, I mean, this simulation does what was that? There needs there's some fishy parts. So we got the getting the free hop. That's fishy. There's something about the network generation that's bugging me. It's there's something about it that's bugging me. And then also, in this, your cache only grows, which is troubling. You don't ever remove anything from cache, which is troubling. And it's going to mediate itself somewhat, but I think you're getting a lot of free caching. Because think of it this way: at the beginning of the simulation, right? Nobody's added anything to their cache, right? A query's run. The first time a query's run, somebody just got a free top X% if they got the query. In other words, the first query you run, the top X is anything,
Right.
as long as it includes that one. The second time you run, and as you run more queries, you're going to be seeding your cache with tons of stuff that in the end result probably wouldn't be in the cache.
What only happens? It only does the top X after it's hit with X amount of messages or queries.
Okay, but still, after that point, at that point you get your top X. But that top X is not going to be the same top X that you see later. Right? So what I'm saying is as the top X evolves over the life of the simulation, anything that's touched that top X is in your cache. Right? So if I have top X, my cache contains my files and the first top X. If over time the top X becomes a completely different set, I still have in my cache my original set of files, that first top X, and now this new top X. You see what I'm saying?
Yeah.
Your cache is only growing, and it's actually getting very poor views of the network at the beginning, which means that by the time the real top X comes out, you not only have the top X, but also all those poor views of the top percentage of the network beforehand. So you're going to basically, you have a very good chance of having most of the files in your cache by the time this is done. You see what I'm saying?
Yeah.
So, and I say that, but the problem is we don't know whether that is happening because of the relationship between the number of queries that we're doing, the number of files, and the number of nodes. I don't know if we're doing enough trials that you'd actually run into that phenomenon. In other words, would the top X change enough that you'd actually get caches that are 2, 3, 4, 5 times bigger?
Well, I think what I was planning to do is fix that anyway. I was just cheating by adding.
No, I understand what you were, by why you were doing that because it is a quick way to start seeing the phenomenon.
I'm going to add in an index list to the smart node for next step, and then for the index list, I go back and remove files. It's not the top X.
But you just need to track top X and
Just the top X.
top X separately from the files. The how it responds is the same as what you were doing, which is pretending like it has the file. You just add one to it and say, okay, it's done. But keeping them separate will make sure that you don't, first of all, start dropping files. Because if you just do it as one big cache and you start taking some out,
You might lose the original files.
yeah. So some of the stuff in there, if those files aren't popular at the beginning, they might get pushed off, which means that now you'll have orphan files that don't have any holder, right? But if you keep top X separate and keep it fixed, you can rotate through those all day long. Like every time you get a top X, you don't even have to add them like that. You just fix it. You say determine top X, and it's just new. Better would be just, honestly, I wouldn't track the number of, you do need to track like the total number of times you've seen it, but just push them into a queue, and then whatever that queue is your top X. In other words, every time you get a query, you see if its age compares to the top X that you're already running. In other words, start top X empty. You get a query. Pop one in there, it's 1. Right? You get another query. I'll pop that in there, it's 1. Another one. And keep getting them until you get to the top. Now, if you ever run into one that you already have in your top X, just increment its counter. Right? So I've seen that one twice. Right? And then just keep your queue sorted by your priority queue sorted by the age that you have on there. In other words, how many times you've seen it. And then as files come in, you keep incrementing, and then if you ever hit any, you just push them off. No, but you still need to keep track of the count. Okay, sorry. You take a queue, empty, right? And you keep adding to it, and eventually the queue will grow to the size of the number of files. Okay? But you keep sorted, and then keep adding, and then just take the top ones, and then just let it keep sorting itself. In other words, just create the priority queue sorted on number of times seen. That way it'll stay there. Anytime you get a query, a message, you can just search the top ones of that as part of your routine of processing the message. In other words, make it transparent so that the simulator isn't doing that. You see what I'm saying? Because that will make it so that you can be pretty sure that all of them are managing them independently, none of them are seeing anything, getting information they're not supposed to, and that your queue never grows. That'll keep it fixed. And then you'll eventually get all of them. It'll also tell you things like whether or not they all see it. If you stop once you found the file, it doesn't propagate it all anymore.
Yeah. There's.
Yeah.
I mean, each node that you process still holds a message, but if it gets another message,
It'll just be also, many of the operations you're doing, I'd go look up some of the traditional algorithms for doing some of the operations just so that you can simplify some of the code. Like, go get yourself like a nice breadth first search so that you can just make that a method. And not just for object orientation. I'd subclass smart node under node, and then make it so that you should be able to run the same simulation environment for both of them. The only reason I'm saying that is that you can start changing more of the parameters and know that they're both getting the same amount of information and that everything else is. In other words, if you implement your caching algorithm inside the node object, you know that it's just your caching algorithm that's getting you a change in these values, right? Whereas the simulation environment, running it outside of that and looking at a generic kind of superclass, interface, where you can just sit there and send it queries and the results pop out, you know that whatever you do inside the smart node, you know is completely isolated from global information. You know what I'm saying? Because there's no way for it to get that global information in. I'm just saying, obviously it's a good object orientation practice, but more than that, it keeps you honest as far as like what information you have and stuff like that. And one other thing for a minute is looking at. Okay, so right now we're looking at a lot of averages. We want to see more ranges of values because what we want to really see is average values that are doing good and then like large ranges where we know we're not just centering. See, because if your average is something that you like and the range of values for it is very narrow, we don't know if we're just moving. The range is very big, and we're getting average values that we like consistently. It means that the phenomena is good. It's not really just the fact that I only asked 3 times, so my average is going to be 3, or some other related thing just from our arbitrary parameter. So, for example, average number of neighbors, right? You say I want the average number of neighbors to be around 3. Well, if it's narrow, it has to be around 3. In other words, if your only choices are in a small range that are around 3, your average has to be around 3. But if it's a large range and that there could be anything from 0 neighbor, 1 neighbor to n neighbors, we know that they exist, that there's some nodes out there with that, and our average is around here. We know that that's our distribution instead of just our range is small. Right? If your range is small, your average is going to be within that, right? It has to be. There's no other value for it to pull from, right? Just the low, just get some information on what the top and low, the low and high values are, and just look at them and see if it tells you anything. Like just say, oh, okay, well my number of queries, the average number of queries that a node sees is this, but the range is this, and you know that different parts of the network are seeing different things, which is what you're interested in. Right? It's like the idea is that by these nodes tracking a particular percentage, you'll get more confidence that they are all seeing a different top X. But they're getting an honest top X, where they're seeing a particular set of queries, and then this is the top ones from this query. And then you can start seeing, well, my averages are going well, so those individual views of the top percentage are actually converging towards the global top percentage. And I'm not sure, and also looking at those ranges of things, I'm not sure if those values, we're not worried about how big those values are, except for the fact that the bigger and more trials we run, the more we'll start seeing we'll start guessing what the average is. Yeah, better distribution of averages so that we can actually be converting towards the true average of these parameters, right? Of this many nodes and this many random nodes in a uniform distribution, this many random files in a uniform distribution will create a distribution of averages, which is actually this. Okay? Because doing stuff where there's random aspects to it, finding things like average means I'm going to find averages of tons and tons of trials, and I should create a curve where the biggest part of that curve is the actual value of this phenomenon, of this. If I were to run an infinite number of all the simulations using this many number of nodes, this is what the value would be for the average if you were to total all those up. But I forgot my point. We don't know how those constants that you're using are relating to each other. 10,000 queries for that many files and that many That might be a drop in the bucket, but we don't know. But the other thing that we don't know is, are we creating like that phenomenon I was saying, where we have a top percentage, and then it would evolve to something else and have a different top percentage. So now we have like a huge cache of all these different views. I don't know if that many trials is enough where something like that would happen. I suspect it is, but I mean the thing is each query, each file can only be, or on average will only be re-requested 10 times, right? So for 10 times of us actually hitting the same file on average 10 times, a complete change of the view of the top 40% of queries might not, we might not really see much change there. So, what that means is that the more queries we see, in other words, hitting a query twice probably does, actually maybe that is enough since it's only 10 times. You'll see like a view where all of the top X all have values of I've seen you once, right? But the second you get another thing that gets hit twice, that would be a complete, it's not really hard to push to the head of the top 40% if each of them will have up to around 10. In other words, number of times seen would be 10 on average. So, knowing some of the range, I think your biggest concern though is getting stuff pushed out of the cache. Making sure that you're getting stuff pushed out of the cache. Because obviously, if your cache can only grow, in other words, there's no downside to caching, you're just basically just, every node is just getting smarter and smarter and smarter and smarter, and that will always get you, If you can just get smarter, there's no downside to that.
Wish I could
Right?
just get smart.
Huh?
Wish I could just get smart.
I know. It's like, in that case, you're not, it's like, the rest of the nodes are just, these are superheroes. Superheroes with no weakness. Superhero with no weakness is boring. So, right, nobody's impressed by a superhero with no weakness. But a superhero with a weakness, we can work around that. You're impressed by it. Right?
Although off topic, I think you're underpronated.
What's that?
You're underpronated. The way you walk your feet, you underpronate, I think.
Yeah, my shoes, about my shoes.
Yeah.
Did you notice that?
It's really bad.
My posture's horrible too, so. Sleep on yourself. But see, notice you're the one with the muscle spasms in your leg just almost knocked over a possession vector. See?
Does that
My
happen?
My sedentary lifestyle, I'm safe. Alright, looks good. Looks good. But yeah, if those things, practice some of the software engineering things that you've learned throughout the years because they actually do make sense. It wasn't made up. Alright, looks good.
I think the whole object-oriented thing, it'll pass over.
Yeah.
We go back to cutting and pasting.
What do you got? I mean, object orientation makes sense in its place, but even if you're going to do that, if you're going to cut and paste, you should have good cutting and pasting.
No, I don't cut and paste. I learned my lesson. I used to cut and paste the bad code, man.
Then you have to learn more about find and replace in all files, right?
Yeah.
All right. What do you got, Richard? You said
I
you're running into something with your.
Yeah, just how we were gonna work it, how we thought we were gonna work it. That's all I was. The query thing. All right, I think the last
How
thing
were
we
we
said.
going to work it?
Yeah, see.
No,
That's the right way.
you're talking about like the synchronous waiting for.
No, well, no. What I ran into is all right. What was I doing? We had, like, you had the query handler,
Mhm.
and it would receive a query. It would send.
Oh.
We had two types. I was going to do the other one. It was
Right, one where it
broadcast.
did just do string. Yeah, it did broadcast pipe.
And it broadcast the pipe, and then it would come back. Then maybe I was just ran into it. It was really hard
It is really hard. I was looking at it too, and
because then I would have had to mimic almost what the resolver was doing with broadcasting.
oh no, I think the hard part is going to be doing all the synchronous stuff because either way, mimicking the resolver, I don't think is. I don't know. I don't think that's going to be too hard. The hard part is going to be doing the synchronous parts, where I'm not really sure how we're going to do it because it's a threading issue as far as.
I don't think I got that.
Because It's the waiting that's going to be hard. Waiting for the result and running something else. Because we need to wait on the node. I mean, on the query. Okay, so the idea, the resolver is the discovery style. The what is it? Discovery service or no? Resolver service. The resolver service style is you send out the query, and then in yours you were waiting, right? You did a wait at that point.
No, it sends it out and then forgets about it. And then it has a listener that's running on the separate.
Right. But when the
And then
listener
once it
came
comes
back, what was
once
your
it
wait?
came back- once you receive the query, when somebody receives the query, I was waiting to see whether we had the file or not. Because that's it. It looks at it. It'll take it and it says, "Do I have this? Whatever the query is." And if no, if I do have it, then you return it or you
Right.
return something.
Oh, so were
to
you
it.
just waiting for the internal paste signal to come back?
There was no paste.
No, when you check for the file, right?
Oh yeah. I was waiting for a paste to let me know whether I had it or not. And then once I got it back, then if I don't have it, then you have to repropagate.
Enough talking to Richard. I'm just gonna open his code.
What do you mean? I explained it. See, I think you're thinking of I was waiting for a different reason now.
I don't remember why we were waiting. Hold on.
I was waiting because you have to know whether you to repropagate the query or not. I was taking
What was that in?
it was in query handler.
Emit query received, paste handler, processed. Oh crap. Ashley Christ, man. But anyway. Response result found.
Yeah, see, it goes and asks, well, actually, yeah, it's asking, do we have it? And if not, then it's gonna wait to find out whether we
Okay.
have it
Where's
or
the
not.
sender?
The sender?
It's up here.
Yeah.
We send query,
Yeah, I don't wait for it.
and then response is it coming back.
Yeah.
We wanted something where we have the send query that goes to the network, and then what will come back is the response, right? Okay. Right now, we have a paste signal coming in, and then a paste signal going out, right? We wanted something where an object out here, a paste object, could query. Right now, a paste object would have a method that does a query, which sends out the paste signal, and then a separate thing which comes back and processes, slot
Okay, I
the
got
response, right? And then somewhere in here is a timer of some sort that says, wait this long for looking at responses, and then if the timer expires, that means you never got a response. If the response comes back, then you obviously got the response, right?
Oh, you want to wait. I see what you're saying.
So I want this tied together into the same method with a wait.
Okay.
You see what I'm saying?
Uh-huh.
So what would end up happening is we need to use, the best object to use is the signal. Right? Where you basically wait on the signal here, and then over here, this handler is getting the signal, right? It sends a query. A response comes back. We should signal notify here. Right? And signal notify will wake up this thread and let it continue. So the main thing here, though, is that there needs to be an emit, like an emit now type of thing here that will get it out of your queue, that will get it out of your thread, in other words, to the parent thread above you, or directly to the network thread
Before you sleep.
before you sleep. Because if you sleep, you have to wait for your queue to process in order for it to get emitted. Right?
Yeah.
So this is a fire and forget emit as opposed to the
And the
emit
queue is actually on the same thread, so if you sleep, it'll just freeze the queue.
it'll freeze the queue. Now, if you emit into your own queue, when you sleep, you'll never get to your loop to make your queue move forward. So what you need to do is emit into the queue above you, then you can sleep.
Okay.
Despite the fact that there may be other messages waiting there, you don't care. You want to sit here and wait.
Okay.
So it's kind of this together is like swings, invoke late, or invoke and wait, where you invoke, the queue processes, and once that event's handled, you can continue. Right? So evoke, invoke, and wait.
Okay.
Right? So these two are somehow together. You synchronize on the signal gets notified. So even though all this is happening, these are actually juxta threads that are handling this asynchronous part. Right?
Uh-huh.
So they do a bunch of stuff, and then response comes back, and then we notify, and then this guy can continue. And so now what we've eliminated, no timeout. There's no timeout here. Okay, because the timeout is now in here in the wait. You can put a timeout there if you want to have a timeout, and then you can process the response. And it's actually viable to have the signal itself contain the response, right? Where we don't have to wait for another emission from the response part. So in other words, you can take all of this out, right? So now when the response is here, actually you do this. Juxta sends out, gets back a response, modify signal, make its payload have the results, and then you signal notify.
Oh.
You see what I'm saying? So now, in one step, we've kind of made it so that we sent out a query, got the response, and then we're holding the response array. Okay, this is kind of a leapfrogging of the pace signaling. You're skipping a bunch of steps in all the pace signaling and just doing it synchronously in that one piece. See, you just need to make sure that when you call something like this, you're not tying up a bunch of that object's thread. See, this doesn't have as much impact now that each of our objects has its own thread, because all our other objects around us could be doing stuff. We just know that this object itself is waiting. And see, the other thing is having it come back directly in the signal, we don't run into the problem of, if we emit this back to it, we can't wake it up by emitting back to it, because we know it's not processing its event queue, because it's sleeping. So we need to make it so that we just leapfrog all that and say, okay, look, wake up, and just go ahead and start processing this message. Otherwise, you'll have to go through all of your queue until you get this response that I emitted to you. So what we're saying is we don't want to wait in line. We just want to do it all right now, wait, and then process it, and then be done. So that's all of that is the processing of the one signal that we started all this with, of needing to do a query.
Alright, that cleared it up.
Another thing is just breaking out the stuff in File Manager into a generic bulk transfer thing.
Oh, yeah,
I looked at it a little bit, but I didn't really get into coding it.
And the bulk transferring.
In other words, right now File Manager is actually doing its own transferring the file over a pipe.
Yeah.
That needs to be broken out into just a pipe.
I was gonna
Transfer.
do that. You said move it up to pace, right?
Yeah, move that up. Move File Manager up to pace,
Yeah.
and then the actual transfers are in.
And then we also talked about. Never mind, I'll figure it out.
Alright.
I don't think
But you're gonna write something on this other paper that you saw?
Yeah.
Right?
I
The
was gonna
group
do,
trust?
doing group trust.
Okay.
Because I figured it's something, as a step we're getting authentic and
Right.
we need so.
Oh yeah, there's tons of good. I wanted to get more into that, but we mostly just spent our time coding, which is fine with me. That's cool. I mean, write some code and learning about what's happening on under the hood is just as good as that stuff at this stage. But next week's our last in-class stuff, right? Next week, have a rough draft together of what you want to write, and we'll do like a little bit of presentation on that, and then I'll be pretty, and then I can, by the day of whatever this class is scheduled to be the final, just get me the final copy of your paper, and then if you have supplementary code like yours, just give me the code, or if you check it into if you can get it checked into CVS, you can just that's your submission.
And there's no reason for our groups to ever talk to or exchange anything with each other. Is there?
Right. Within, like, in other words, for there to
'Cause
be
we have
scope outside of,
application
yeah.
There's
No.
no reason. Yeah.
No. Any inter-group communication will be done through pace signaling. In other words, like getting to the file manager, that's a
Right.
separate group, but it's done through pace signaling. There's no reason for the file manager to ever.
Well, no, I was just thinking from because I was looking at group trust and it has a lot of stuff, inner group, it sets everything up into peer groups. And then it deals with transferring.
Like there's gatewaying between two different groups. I mean, well, see, that's the thing is, in pace, or in any, in these types of, this type of peer-to-peer network, there is intercommunication between them in the sense that the entities are shared among the groups. In other words, you might be able to, it would be, may or may not be a feature if your trust that you gain with other nodes in one group transfers to your trust gained in other groups. In other words, if for example, your signature carries a particular weight, it may be desirable that if through all your interaction in this one group, your signature gains weight, when you use that signature over here, you kind of have a jump start on how much you trust other nodes through that. Because most of these peer-to-peer networks, trust is gained by participation, by participation over time. The more you participate, the more you contribute to the network. It doesn't matter whether, as long as it hasn't been detected to be malicious in any way, you're kind of getting more and more experience. It's like with people. The more and more experience you have with a peer of them doing it, you ask for something, they give it back, and they ask for you for something, you give it to them, and they say thanks, or whatever. And the more you interact like that, the more you kind of gain status with other nodes. But just because you have status with a particular node, that's no reason for another peer to trust you at all, unless you start getting into these kind of group trust type of things where they can ask you to vouch for them, and then you say, oh, I trust them this much. Okay, I'll trust them a percentage of that much just to start off because I trust you this much. I'll take how much I trust you, how much you trust them, do some sort of combination of those and say, okay, that's your initial starting trust. Because I know this person has been participating correctly. You've obviously been participating correctly with them. I'm going to assume you'll participate correctly with me, right? So those types of things. So having that kind of interaction, that would be probably a beneficial mechanism that I'm doing a parameter sweep application over here. You guys are doing a clustering application over here. We start doing some sort of different computation here. You can say, oh, well, I know you were doing this computation with Nick, and I was doing a computation, and so now I'm going to go ahead and start you off at a particular level of trust, as if those keys are global, but the participation is local. In other words, the building of trust is local, but the currency that you have on that key, and what I mean by key is, if you're signing stuff with your name, that's your identity as far as everyone's concerned. Whatever your public key is that you're signing stuff. The private key that you're signing stuff with, I have a public key view of that. If I keep signing stuff, I'll start seeing that public key as having a particular amount of weight. But yeah, all those group kinds of trust things or group signature type things, or I don't know what the particular paper you're reading was talked about with the group trust, but there's a lot of different nifty mathematical mechanisms for measuring those things and keeping them, making sure that you're measuring the right amount. And in other words, that you're not just saying, oh, I'm Reed, so just okay, and I'll start doing stuff, and then some other person just starts messing around saying, oh, I'm Reed, like going to Oregon and
Yeah.
like and like stealing all your stuff, and then all of a sudden, next thing you know,
You're getting
no
fired.
one's going to be transferring files for you because some Nick in Oregon was in their base stealing all their files. I don't know. All right.
So, what's the deal with me? I mean, not like concerning workload. I mean, concerning like credit.
No, from what I understand, I mean, I'm going to talk to Dr. Parent about it, but I mean, the idea is that you do the work. You do the work by. As far as registering, I'll ask him what you're supposed to register for next semester. But does it matter? I mean, what have you done? No, I'm just kidding.
Well, I mean, that's kind of true.
I'm just kidding. No, but I mean, so the deal should, I don't know. I'll find out what you need to register for. But once you register for it, you basically just turn in what you've been doing. Hopefully more, like that you can do. Continue next semester. That
Of course, this is a 2-semester program.
right. So and then you'll just get credited for that. So I'll talk to him about what you're supposed to register for. And
So this is like a primer for next semester.
yeah, this was
Let's get my feet wet.
this was just doing some of the work before it was actually the deadline of it and doing it all in the last week. So this is what it's like when you spread the week before finals to an actual semester. All right.